Alright, hey everyone, and welcome to C++ Week 5 on Monday, May 7th, 2012. I'm here, and I am Nelson, and Gavin is here.
Hello.
Hey.
I'm not Nelson.
No, you're not. And Jason will be arriving shortly. Okay, so this week is going to be pretty easy and straightforward. Basically, this is the buffer week between what we've learned so far and getting into more advanced things. Like next week is going to be all about pointers, and the week after is going to be all about object-oriented programming. So this week is a week for people to really catch up with what they've learned, and for people who have been following along, we are going to be introducing some cool stuff that that again is very straightforward to teach.
So give us a quick rundown of what we can expect this week.
This week we're going to be talking a little bit more about debugging with functions. We covered that a little bit last week with the call stack window. We're going to be just talking about it again, just straightforward stuff. We're going to be talking about enums for a little bit, which will be fun. Again, very straightforward stuff. We're going to be talking about simple file input and output. Straightforward stuff. We're going to be talking about structures. Now that's going to be some fun stuff. Again, pretty straightforward stuff. We're going to be talking about creating arrays of structures, which isn't a very large discussion either. And then we're going to be talking about the vector class, which is going to be very fun. In addition, depending on how things go, I want to introduce a basic use case for pointers. Not getting into a huge discussion about them or the other fun stuff you can do with them, but a basic introduction to pointers so that the homework that I'm going to be assigning can be done properly. And also, this week we will be making sure that everybody's caught up with what we've learned so far. So again, it's going to be a bit of a laid-back week, so that people get comfortable with. Well, because we've been introducing things left and right, so this stuff is going to be, and that's the title of this week is Stuff and Things, which was actually just a placeholder title because neither Jason nor I could come up with a name for this week. So that's what it's going to be. And yes,
let's get going.
So feel free to ask questions about things that you may still be confused about, because we'll have time for that during this class. Because again, straightforward stuff doesn't require a whole lot of discussion.
I will say it just for the umpteen people who seem to forget between week to week. If you have questions for Nelson, please put them in the webinar questions panel.
Yeah.
And if you don't, then don't get sniffy when they're not answered.
Something I really despise that the Visual Studio 2010 doesn't do that the next version does, is that when you create a new console application, it doesn't auto-name the name. So typically it should be like console application 1 through X, but here you have to enter name, which is why you've seen me do this, basically. It's just a really frustrating thing that I despise.
Oh, good.
Okay, so I'm going to go ahead and add a main.cpp, get some headers in, get some namespace imports, get a main function going, and have it return 0, and we might as well just do that as well. Okay, so let's first talk about enums. Enums, very straightforward data type. People might be familiar.
What does enums mean?
Enum is short for enumeration, which has no correlation to what you might, if you're coming from C#, it has no correlation to IEnumerables or IEnumerators. An enumeration is a data type. It's a type that we can describe to the C++ language. And what it does is it makes it so that we can create variables of that type that only have a specific list of valid values. So what we do is to create enumeration type. So, I mean, let's say that we have a main menu system. So I'm going to go ahead and say int menu equals 0. And I'm going to say while true, or how about bool exit equals false while not exit. And then we can go ahead and say switch on menu. Case 0 might say cout, help.
And while you're typing, I'm just going to say Mr. Complicated came up with one of the best definitions of an enum I've ever seen. Enum is statically named integers.
Yes, a bit.
Yeah. I'd never thought of it that way around before. But yeah, that's a very good way of putting it. Oh, of course, yes. We're in C# land now, aren't we? We can do stuff to them because of that. Well, we can't do stuff to the enum. I disagree, so cool. I think that's a great way to think about an enum. Well, you see, I like enums, but then I like switches. And the two kind of, a lot of the time, go hand in hand. Because, obviously, a switch works best if it's got a definite and finite number of things that you can switch on. Otherwise, you end up leaving most of the functionality in the default state, and it becomes pointless having a switch. And of course, because an enum is static and finite by definition, they're great with switches.
Okay. Wait a second, what? Oh. Okay. So what we have here is a very, very, very simple program that allows us to transition between different menus.
Do you want to go ahead and copy your main into 2 columns?
I mean, what, like that?
Yeah. So people can see all the code.
Yeah. A very straightforward, standard way to do menu systems in any programming language, typically. So we have a main menu. We can type in new. We get to the new state. Let me go ahead and add some new lines. We can switch between...
Florum says...
What?
Florum says he wishes the switch would auto fill in Visual Studio C++. Afraid that's a resharper thing.
Yeah. So we have a basic program. We can type in new. We get to the new state, and the new state simply transitions back to the main menu state. And same with load, save, and help. Very straightforward stuff. Does anybody have any questions about this code or how it works?
Somebody should scroll left side up, please. K73 said, it's over 40 lines, you fail.
Okay, so again, basic program. We have a int menu equals 0 variable. We switch on menu. For the case 0, we print the main menu. For case 1, we print the new menu. Case 2, we print the load menu. For case 3, we print the save menu. For case 4, we print the help menu. And you'll notice each one of these, just to keep the examples short, they immediately transition back to the main menu. But the you can create a nice, with this sort of scheme, you can create a nice little state machine framework type thing. But there's a problem with this code. The biggest problem with this code is the menu variable. The menu variable has no semantic value whatsoever. It is literally just a number, and there's nothing here, for example, on line 26 that speaks to you that says menu equals new menu or menu equals load menu. There's no semantic value on line 45 that says menu equals main menu. So there's two ways we can go about doing this in C++. We can go ahead and do defines. We can say define main menu state 0. Define load menu state 1. Define save menu state 2. And then we can replace all of our little constants with these defines. So that's one way to do it. However, we still have a problem. Defines are not something you would typically want to use anymore for constant values in C++. Because they don't carry any type information. And because they don't carry any type information, they don't necessarily work in situations that you'd expect them to, and as a result, they should typically be avoided. Defines are a more archaic way of defining constants. A more appropriate solution might be this, using, well, constants. We can say const int main menu state equals 0. So we solved the problem of carrying a type with our states. So now all of these state constants are typed, which is what we want in working in a typed language like C++, and what we want when dealing with type safety. However, we still have another problem. The biggest problem here is this integer. You see on line 12, we assign menu to the main state menu, and it's an integer. There's really nothing constraining menu to be anything in particular other than an integer by convention. There's no real semantic value whatsoever that correlates the type of our constants to the type of the variable that stores our constants. In addition,
well, for instance, if you changed the line 4 to equal 5, for instance, all of a sudden now people are going to be entering 0, and the switch case for main menu state isn't going to fire. Well, because it's no longer equal to 0. We've immediately in one key press broken our code.
As far as you mean like line 50, line 55?
Yeah.
If they had been replaced with this, we would have, that would have worked. However, this code, the fact that this code is even valid is a concern. The fact that we can even do this legally, set main menu to 0, or in fact to any arbitrary integer value, is going to be a concern within our code. Another concern is the semantics of a function that takes in this menu. So for example, we could have a void print menu int menu. Well, what do we pass into this parameter? What argument do we pass in? It's not really, it doesn't speak to us. It doesn't give us any hints as to what this function expects. So it's problematic. So enumerations are a way to not only correlate constants with the type, but to also correlate constants with a specific meaning and a specific purpose and a specific connotation.
When you say we had some questions come in.
Yeah.
When you say semantic, are you referring to meaning?
Yes. When I say semantic, I'm referring to the meaning of the code that is not necessarily cared about or isn't cared about whatsoever by the compiler or the computer, but that is a very important aspect to a human reading your code.
Because otherwise you could call these menu state 5, menu state 1, menu state 2, the constant ints, and all of a sudden you lose the semantic value you've got by calling them main menu state, load menu state, save menu state. And so that tells you what it's doing.
Yes, and if I name this function that, computer doesn't care. Doesn't matter to the computer, but it does matter to humans reading your code. Okay, So we did get a question, what's problematic about setting main menu state or menu to this? There's nothing problematic about this immediately recognizable, but what is problematic is that the language allows us to assign int menu to a 0, because menu is an integer. And an integer has a range of valid values ranging from, what is it, -2 billion to 2 billion as far as assigned integer. And that means that this type has no constraints and can be assigned to any value that we want. It allows us to write code like this, which isn't something that we would necessarily want or think is valid. Because right now this code shouldn't be considered valid because we are using constants repeatedly. But the language allows us to do it, so it's easy to forget. It's easy to accidentally screw up and send an integer value into main when you really wanted it to be constrained to the range defined by our constants.
Yes, as Segfault just screamed in BuzzNet, we need constraints, although, you know, that could have just been coincidence and it could be something going on in his personal life that we don't want to know about.
No, he's exactly right. We need constraints because constraints tell us what the range of a variable's valid values are, which gives off so much important information as to the readability and understandability of your code. So what they did in C++, or they did this in C actually. Enums existed in C, but they're a lot uglier. Typically, everything that exists in C that exists in C++ is a lot uglier in C. But in C++, what we can do is we can define an enumeration. Now, an enumeration defines a type. So you start by typing in the enum keyword, and you follow it with an identifier. I'm going to call it menu state. After you give it an identifier, you open up curlies, and you terminate with a semi. Now this is very important. This semi will trip up every C# or Java developer in the class, because the semi isn't
silly.
There's actually a use for it, although it's a bit of a silly use itself. But do not forget the semi. It's very important. All types in C++ are terminated by semis. Okay, so what can we do inside the main menu state? Well, I can say something like main menu, load menu, or even just main, load, and save. But you'll notice there's going to be a slight tiny issue with this. But we'll talk about that later. And once we get into structs, I'll show a proposed solution to the problem I'm about to address. Okay, so now we can nuke our constants. We don't need our constants anymore. What we've done is we've defined a type that has 3 valid values. We have created our own type that is type safe when used as parameters. And it only has 3 valid values, main, load, and save. Now you'll notice when I hover over these, they correlate to integers. That's because enumerations are basically wrappers around integral data types. So we can have an enumeration, well, I'll go about that and go into that in more detail. But the idea about enumeration is it sort of decorates like for example, an integer in this case, and constrains that integer to a specified range of valid values. So you'll notice main is 0, load is 1, and save is 2. So now that I've
help, it'll automatically go in at 3.
What? Oh, help.
If you were to add help,
yeah,
it would automatically be...
Help is going to be 3. Okay, so how do we use our menu state? Well, this is a type. And what can we do with types? We can use them as variables and parameters. So I can go ahead and say menu state, and then instead of our print menu, actually I'll address this problem in a second, because it's less obvious because I don't have a body in this method. But if you look at line 20, you'll notice an error because I deleted the main menu state constant. So let's talk about how we can use this type. Instead of declaring menu as an integer, I can declare it as a menu state. Now I can only assign it to main, load, save, or help. I want to point this out really quickly to people who are familiar with Java or C# or other languages that support enumerations. C++ enumerations are essentially just constants, meaning they're constants with the additional concept of a type, meaning you do not prefix the members of an enumeration with the enumeration itself. You do not say menu state : main.
Ooh. Oh, go on, then change your names then. Please.
Yes, well, that's good. Yes, that's going to be the problem. So we're going to call this main menu, load menu, save menu, and help menu. So now I can just type in menu state menu equals main menu. Yes, it is a bit ugly, but once we will be talking about a way to fix this problem. Does everybody understand the problem that I'm referring to? Basically, instead of saying menu state menu equals menu state main menu, which is how it should be, we simply say main menu. So all of our enumerations kind of get cluttered, or kind of get coalesced into the namespace that they're declared in, which is kind of gnarly. If they're constants, does that mean the enum values do not have memory allocated to them? Depends on what you're talking about. These values right now have no memory associated with them whatsoever, because they are just constants. However, any variable you create with your enumeration type does indeed take up the same amount of memory as the type that this menu state is wrapping over. So in this case, menu state is by default going to be wrapping over an integer type, meaning that every variable of type menu state will take up 4 bytes. Wick asks, can I do if load plus save, or how about load menu plus save menu equals help menu?
Yes. You can, I'm guessing.
Unfortunately, you can. Although this doesn't, you can perform arithmetic and bitwise values on enumeration constants. But here's the thing: this doesn't make any sense conceptually. This is basically just like saying if false plus 1.
Essentially, yes, it is one of those things where you're basically taking advantage of it being broken and not stopping you. But don't.
Yeah.
And we did have a question come in. I noticed you've nuked it now. No, Wolf. Menu state : main menu doesn't work. That was, she was showing.
Yeah, this
that it doesn't work.
Does not work, but it should work. And it should work because these values should really be scoped into a container, like they are in C# and Java. Because these values are so closely connected, and they are only valid to be assignable to a main menu state variable, they're treating them like global constants will clutter up your namespace and cause you misery and reduce the findability of your code, especially as it relates to IntelliSense. So for example, if I type in main menu, if I just type in main, you'll notice main menu's there, but there's no other constant values next to it. It screws up our IntelliSense. However, if I do menu state : you'll notice this. I do want to point this out really quickly. The IntelliSense for Visual C++ does actually allow for this syntax because Microsoft added a language extension that allows for the syntax. But because I'm compiling with language extensions turned off, it's not going to compile. But this is what it should look like. So it should be menu state : and then you should be able to access all of your stuff. Someone says it did compile for them. I'm pretty sure I tested this before class. If I do Control-Shift-B, I get a
warning, non-standard extension used.
I get a warning. Non-standard extension used, enum menu state used in qualified name. Okay, so I misinterpreted that earlier as an error. But you should treat this as an error, and here's why. This will not work in other compilers. So this does build because I do have Visual C++, that gives me this language extension. But this is a language extension.
Yes, K73 just nailed it. He said, okay, we'll ignore for diversity. Yeah, if you're not the only one that's going to be compiling this, don't do it, and thus don't get into a habit of doing it.
Yeah, don't do this. Don't ever do this. We're going to go over a technique later that will let a similar syntax work in a standard way.
So yes, so you should do it, but don't do it.
Well,
once
we talk about a way to get this to work within the constraints of C++, then we can do it.
Woo.
Okay. So again, just to reiterate, enumeration should be treated as unique entities. Think of it, you are defining the existence of acceptable values. And you are not, when you define an enumeration, you are not defining a relationship between the values. So for example, let's back up into basic numbers. 1 exists because 1 is defined. 2 exists because 2 is defined. And then there's a relationship between 1 and 2. There's an arithmetic operator, addition, that provides a third value given that that operation is applied to the numbers 1 and 2. So if you think about numbers as symbols or just things that only exist because they were defined to exist and behave in a certain way, that's exactly what an enumeration is. We define the existence of main menu, therefore it's there. We define the existence of load menu, save menu, and help menu, but we do not in any way define relationships between these values. There is an implicit relationship in that they are incrementing in their behind the scenes value, but that's a implementation detail that shouldn't be typically relied on unless you are working with a platform or maybe some compatibility with older code. Where you might need to override that behavior. But think about...
It's literally, I mean, you can look at an enum as just, it's literally like a row of houses. There are a set number of things with set names that you can use, and that's that.
Yes, and there's no...
If a postman has a letter for number 24, but there's only 23 houses, he can't build a house in order to deliver the letter.
Right. And if you take house 1 and stick it on top of house 2, in addition, that operation isn't defined.
Yes, things will break.
Yeah. So think about it like we're defining our own number system. So if you were, again, to think about the numbers, let's say arithmetic only had 2 numbers, 1 and 2, and arithmetic defined the number system 1 and 2 to behave in certain ways given operations. That's that number system. This is a different number system and has conceptually no correlation to the underlying implementation. At least conceptually it doesn't. Although that behavior, again, is useful when dealing with legacy code or interop with other platforms. But if you are designing an enumeration for your own purposes, you should avoid thinking about enumeration values as integer values.
I'm going to summarize this question briefly into whereabouts should you put enums?
Depends. It depends on if the enumeration is only used internally to make a CPP file work. So for example, in this case, menu state is only used as a local variable to main. Therefore, its most appropriate location is inside the main.cpp file. However, if I was defining, let's say I was defining a .h file called products. And it had a void function called setProductStatus, and it had int product ID and then product status. At this point, because the prototype for a function requires that we pass in an enumeration, you must define that enumeration inside the .h file immediately, or not immediately, but at some point before you define the prototype that relies on that enumeration. So then I would say enum product status, and then I would say in stock, out of stock, back ordering, I don't know.
So two related questions. Can you And would you forward declare enumerations? I mean, not forward. Do you know what I mean? What's the word?
You
Template them out.
Well, you can't. Well, here's the thing: an enumeration is just an enumeration. It has no implementation. So you're not going to get a linker error for having multiple definitions of enumeration, because at the stage of linking, enumerations do not exist. They're replaced with integers or whatever you define the backing type to be, and constants. You can forward declare an enumeration, as in you can do this, but this only works when the as far as pointers go. This is only usable for pointers, and we'll talk about that later. You wouldn't typically do this, but you'll do this for classes and structures. You'll forward declare them so that you can create circular dependencies inside of your classes. But in this case, you would, if you needed your enumeration to be in your header file because you used it in the signature of your prototypes, then you would declare it in your header file, and you would declare it in its entirety in the header file. There's no reason to have enumerations be external because they don't have any. Their enumerations are a compile time thing only. That's it. They're only compile time. After compile time, when it gets to the linker stages, enumerations don't exist. The linker doesn't care about enumerations because they're replaced with references to integers typically and constants.
Gotcha.
So,
yeah, that's what confused me just now.
No point to make them external, and you would only put them in the header file if they were used in the signature of your methods. Because, well, per definition, because you can't. If I did this and someone included products.h, they wouldn't know what product statuses were. Okay, so jumping back into main. So enums are just for code readability. They're used for code readability and a safeguard. Because watch this. By using an enumeration, we have solved some of our problems. The first problem we have solved is that whenever we have a variable that we want to constrain to these 4 constant values, we can call it a menu state. So for example, my print menu function, I can have it take in a menu state now, which means you can only pass in 1 of 4 values into it. So that's great. I've now constrained the possible correct values for this function, and I've made it not only more readable in the sense that somebody reading this code would instantly know how to use it, but also not possible for you to pass in an invalid number. And again, that's stupid. So now...
Surreal said, so you're making your own type. Yes. Mm-hmm. And like you said before, it's a wrapper around the integer type. And it's basically like a bouncer saying, are you 0 to 4, 0 to 3? If not, you're not coming in. In this case, it can be main menu, load menu, save menu, or help menu, which equate to 0, 1, 2, or 3. There are no other options.
So yeah, can you show us the small values of enum? I'm going to go ahead and refactor this code to use enums, because you'll notice we get some very nice things by changing the type of menu from an integer to an enum. The first thing...
Well, yeah, go ahead.
The first thing is line 29 fails, obviously, because we no longer have a main menu state constant. Instead, we just have a main menu. Now, here's the great thing. Line 39 has a compiler error on it. I'm so glad that that C++ actually enforced a semblance of type safety in this context.
I'd quite like to just put this out as a question to everyone. Why are you getting that error? Anyone who we know that you know that you know that we know that you know that we know that you know knows, don't answer. But if you don't know that we know that you know that you know that we know that you know,
I think you added too many.
You think you don't know that we know. I'm just filling time while people answer, basically.
No, it's if you know that we know that you know. If we know
that you know, and you know that we know that you know, or you think that we know, or you know that we think that you know, Yeah, let's...
Pointer to a pointer to a pointer to a reference array, pointer, pointer, reference array, pointer, reference array. Don Clover doesn't know anything anymore?
I know. Or at least I think... Do we have any proper answers come in? Or is it just people replying to my silliness?
Is this you know we know thing going to be on the test? Yes. So be sure to rewind the video once you get it and take notes.
I should write it out using not and and.
Okay. So yeah, people say it cannot be anything other than stated. Is the menu state... You what?
Would you just want to rub that in one more time?
Yeah.
You cannot change an enum because, like Nelson said, it's a compile time constant. Once it's compiled, it's just
numbers.
A value.
Yeah, it's just numbers once it compiles. This is purely for the benefit of programmers. It's not for the benefit of the computer whatsoever. And it won't have any performance implications that an integer value wouldn't. Okay, so yeah, people are talking about type safety. Basically, we cannot assign a menu state variable, and menu is a menu state variable, to anything other than what's defined under the menu state enum. So by assigning it to 1, we get a nice little error, and thank you, C++.
Sorry, I'm going to pick up on this because you always say it backwards. You're assigning 1 to menu, not the other way around.
Yeah, you're assigning 1 to menu, and thank you for C++ for doing this. You let us do false plus 1. You let us do pointer arithmetic. You let us assign characters to strings. But you do not, thank you for not letting us assign integer values to enumerations. Sounds very similar to C# enums. Yes. Well, the biggest difference is this. And yeah, conceptually it is similar. I do want to point out that C# and Java enumerations have have a concept of a runtime existence, whereas C++ enums do not have a concept of runtime existence. So there is one difference. And the biggest difference, though, you'll see from a programmer point of view, is that you do not prefix your enumeration states with the enum itself. But anyway, so let's make this code work. So main menu equals new menu, or what did I call that again? I don't have a new menu. New menu. Menu equals load menu. Menu equals save menu. Menu equals help menu. Now, this equals main menu. And we're going to change all of our zeros to main menu because that code now does not work. Now here is one sad thing about C++ enums. You can, when you switch on a C++ enums, switches don't have type safety typically. So you can switch on constant values, and that's going to be legal. So it would be like doing if menu equals, or sorry, if menu equals 0, and the difference, there's no real difference because although you cannot assign a enum to a integer value, you can implicitly cast an enum value into an integer. So as a result, the switches do work as well as if statements, which is an unfortunate thing, but at least we can assign them to incorrect values. So let's change... You what? What was that, Gav?
That's all right. Sorry, I forgot you hadn't quite done with those.
Okay. So now when I run this program, we get the exact same behavior as we did before.
So, with that whole string of ifs and else ifs that you've got in there, inside the main menu state.
Mm-hmm.
Could they not be a nice tidy switch as well?
Could be.
Now, because again, you're enforcing...
No, it couldn't be. Switches can't compare strings.
Ugh. So you can't switch on input.
Well, think about it like this. Input isn't a built-in type. So there's no way, because switch only works with integer values, and input is not a built-in type. It's a type provided to us by the standard, but it isn't necessarily a built-in type. Because a switch statement is a language construct, it doesn't do things in a way that work. Well.
Beautiful.
What?
No, I don't like that.
Okay, any questions? And did I answer your question about being a small valid use of an enum? We did get a few questions, though. Is it good to give them values like main menu equals 3? And I kind of already answered this.
So what's help menu now?
Help menu is going to be 4.
Will it go 3, 0, 1, 2, 4?
Yeah, it'll continue on from this. So load menu will be 4, save menu will be 5, help menu equals 2.
Oh, right. Okay.
Okay, so does anybody know why you wouldn't want to do this?
Well, it confused me already.
Yeah. And it's perfectly legal to. And there are situations where you can do this. And I said before, treating enumerations like integer values is not correct.
It's kind of defeating the point of having an enumeration in the first place.
Right. Enumerations are handy tools when working with legacy code that has a lot of defines that you want to change. They're good tools for interrupting with other platforms. But when designing an enumeration for your use and your use only, you shouldn't think about them as being integer values. And as a result, assigning an integer value to a particular number kind of defeats the purpose of an enumeration.
Although it would let you put things in alphabetical order, which is always pretty.
You what?
I was trying to think of somewhere when you might actually assign numbers, and the only thing I could think of is if you were reordering or changing the enum in some editing.
Or maybe you're doing like flags to an operating system or something. It's
and different operating system might require different flags or something.
Yeah, it's a different. I'm not really particularly concerned about that use case because we're not talking about interop, really. Okay, just to enforce this being bad, what if you did save menu equals 0? Oh, right. Well, that is going to produce some very interesting errors, because you know how C++ is about errors.
Sometimes it'll throw them.
Well, it'll throw them, and it's typically they're non-obvious. But what you'll get here by setting main menu state save menu equals 0, here's the funny thing. This bit of code will compile, but save menu will be 0. Help menu will be 1, new menu will be 2, main menu will be 0, load menu will be 1. So we'll get some conflicting numbers, which will only throw a compiler error when you try to do stuff like switch on them.
Yeah, because otherwise, essentially what you've done there is you've limited yourself to 3 options, 2 of which are named twice.
Yeah. Like, just to iterate like how bad this is, if this wasn't a switch statement, if this was a bunch of ifs, so let's say, let's turn the switch statement to ifs so the problem becomes even more apparent.
quite pleased about this because it does show up quite well why switches are nice sometimes. So in this case, you've got all this menu equals, else if menu equals, else if menu equals.
Oh, poor Gavin.
As far as you're just typing BR semicolon. Is your dog eating the microphone?
No, that's not me. Who?
That's
You know
me.
who it might
Sorry
be? It
about
might be
that.
Jason.
Ah, hooray!
Yeah, it's
Whoa!
Okay, so what I just did was I replaced the switch with an if-else. The reason I did that was because this will make the problem that we just introduced a lot more apparent. Remember, this code will compile with two of the constants, or two of the constants being the same. So now if I were to run this, and let's say I
Two
type
pairs
in
of constants are the same.
new, we get new state. Load, we get load state. Save, we get save. Help, we get load state. So when we type in help, we get the load state. And the reason that's happening is when we type in help, we're setting menu to help menu, which is the constant of 1. And it so happens that we are checking for menu being equal to load menu prior to checking for menu equals help menu. Because they're the same value, it'll trip up both these if statements.
Ooh, yeah. Move lines 59 et al. Down to the end of your else ifs.
Right, if this was at the end, and we tried to open up a load menu, we'll get a help menu. So assigning constant values to enumerations isn't something you would generally want to do.
So are there any more questions on enums and their use and such like? It's fairly straightforward. The main things, as Nelson said, are probably if you're used to C# or Java, those two little gotchas of the semicolon at the end of the enum declaration and not using the type name.
Yeah. Actually, here's why the semicolon exists at the end. I'm going to delete this function, print menu, and then I'm going to move menu state into main. Here's why there's a semicolon at the end. This currently still is valid code, but with the semicolon, I can actually declare a variable of this type immediately after definition of the type. So I can say enum menu state blah, blah, blah,
quite nice.
and then menu. And now I can delete line 17, because line 17 is being handled now by line 15. Of course, we get an error because we don't assign it to anything.
Can you do that? Can you combine those? So can you add the equals main menu to the line 15?
Yeah. So this sort of syntax is useful for something like a very simple enumeration that you only use in the context of a single function. But even then, it does get kind of nasty.
We lost Wolf with the menu at the end of the enum thing.
Yeah, basically what you can define types in C++ inside of functions. You could even define classes and structures inside of functions. I
was just saying, instead of this being enum menu state, say it was just, and remember, menu state is a type, if it was just an int that you were defining, you would write int menu equals 0. And we're doing the same thing here. We're saying, oh, now you've confused what I was going to say.
Well,
now we're saying menu state menu equals main menu.
Yeah, we're basically declaring the entire type right before the variable instead of aliasing it out into a type. So basically, if you look at it like this, instead of giving this a type identifier like menu state, we're actually defining the type itself in its entirety and then creating a variable of this type and then assigning it to a value. So instead of having this, where we have the type being aliased out into another type that was defined previously, what we've done is we've essentially taken what would have been here and literally copied and pasted it right into this line. Control K plus F. So yeah, it is a bit weird. But Robert, did that answer your question? We are not just defining a reusable type. In this case, we are actually defining the type in its entirety and then immediately creating a variable afterwards.
But similarly, because I'm sure when you first did that, you had enum menu straight and then all that menu equals.
You can give this you can do both. So you have three options when creating a type in C++, and this is true for enums, classes, and structures. You can A, name the type and place it outside or inside of a function. Or you can B, name a type and give it a variable of that type to automatically create. Right?
Mm-hmm.
Or C, don't name the type and create a variable based off that type. So three options. The two options you'll typically use are going to be these two. You'll either create the type and name it and create it external to a function, or you will create an unnamed type, immediately create a variable based off that unnamed type, and then use it from that point on.
And that's really just if you're doing a one-shot to save our own writing.
Yeah.
So I think you should give them something to do with enums, really.
Well, somebody just asked, can you make menu and menu one at the end? Yes. You can use multiple... you can use multiple variable definition. Of course, menu 2 is already defined, so... And this, what you see right here, is why the semicolon exists at the end of types in C++.
For now, we'd really rather, in fact, I would like to, if no one else has any objections, to put a restriction on it that we only use the type you initially showed with the definition as well. But none of this. Don't lay it out like line 16 with everything in one row. Please.
It can be useful maybe if you have like 3 variables. It really depends on the use case. This I wouldn't do. This I would create a menu state like this. For a few reasons. First of all, this is cleaner and easier to read. And second of all, it's very possible that I'll be reusing the same enum menu state throughout my main.cpp file in different functions. So I would immediately jump to what I did on line 6 through line 11. But if I had a function that just had like maybe a function that had 3 states, I might say enum, state 1, state 2, or maybe I'm writing a function that parses a decimal or a float value in text. I might say found dot, or how about found number, found dot, parse state. Because a parse state has sort of, or searching found number, found dot. Because I would want to keep track of 3 states. I can't just use a Boolean, because if I used Booleans, I would have 2 Booleans, a found number and a found dot. But this way, I can now have a Boolean with 3 possible values, searching, found number, and found dot, and it only makes sense in the context of a single function.
And would you? I mean, this is just clearly this is the way I think of them. But I always think of enums as like you just said, as sort of a multi-option Boolean as being the use case for them, really. No,
Yeah, that's pretty much what
if
they
you've
are.
got two things to choose from, you use a Boolean. If you've got more than that, you use an enum.
Would it be good at practice to create a header file called enum and put all enums inside of it? No. It would be best practice to place the enum in a file that makes sense for that enum. So for example, in my products.h file, I have a function prototype called setProductState. I would take, or setProductStatus, I would take the enum product status and define it right here. Because that's where it makes most sense to place that enum. And per definition, it must be placed immediately or at least somewhere before this prototype.
But that is kind of something that I initially found myself wanting to do. Admittedly in C# was create enums. But then when you think about it, just because they are all of the same type, well, the same sort of supertype, they're all enums, doesn't mean that when they're used, they're all used together. And in fact, it's probably almost more likely that one will be used in one part of your program and one will be used in another part of your program. You don't want to be importing them all redundantly each time. You only want one of them.
Right, and to find them, you would want to go to the most logical place to find them. Can I use C++ enums as a generic constraint? C++ doesn't have generic constraints.
Ha!
Okay, Robert, you said earlier that you were lost. Does this make sense now? This sort of syntax for defining the type and then defining a variable of that type? Okay, what's going on here is this is going to be true for every type in C++. You have two options. You can alias a type out into its own definition and name it. So I've aliased this enum definition out into line 6 through line 11, and I've named it menu state, which means I can now use the menu state type whenever I want. I can now do it in main. I can say menu state menu2 equals menu1. Wow, that's a terrible choice of variables.
That's really confusing.
And then I can create another function called print menu that takes in a menu state. So does this syntax make sense, at least as far as having a type, aliasing out the name of the type, and then reusing the type throughout different contexts that it's in scope for?
I mean, this is just, if you think about it, we're doing exactly the same things in the same order that we do with an int, for instance, but we're also having to tell it what an int is with lines 7 through 11. We're kind of, with an int, you can just use it because it knows what an int is, and that's fine. It knows what values are acceptable and what aren't. We are having to tell our main menu state type what valid options there are. And so we do that at lines 8, 9, and 10.
Right. It's just like days of the week.
Yeah. Or colours of the rainbow, somebody pointed out. Dawan Bu 89.
I probably wouldn't do colors of the rainbow just because colors have properties about them that allow them to be combined.
And because you can't spell colour. Or Monday.
So for example, I'm defining a days of the week enum that can only be one of these possible values. And that's all an enum is. So then I could say something like print menu specials given a day of the week. And I can say, well, string special equals blank, and then I can say switch week. I can say, or I can just say...
Surely day of week should be called day. I wouldn't normally do that. NATO. Everyone starts a week on a Sunday in the West.
So here I have a nice little function that does different things depending on what day of the week it is. Where does week come in? Week is a parameter to this function.
Which should be called day.
Oh, I misunderstood what you're saying. Yeah. So day of week day is a parameter to this function. So whenever we invoke this function, we can only give it Sunday through Saturday. So if I go ahead and collapse this code that's irrelevant to this particular example, what we could do now is we can say cout get menu special, and when we pass in, what we pass in has to be Sunday through Saturday. It can't be anything else. So I can type in get menu special for Thursday. And if I run this, you'll see we get special 5, because Thursday has special 5.
I say because we must have been going for nearly an hour now. You should give them something to do.
What are you thinking?
I did my thinking. That involved coming up with telling you to think of something to get them to do. Surely you anticipated me saying that. It's not like I've said it in every class for the last 3 weeks.
Well, I say we probably... so how do we do that trick? We'll look at that in a bit here when we talk about structures. So, okay, so how about... Enum to track current season. How about...
What about one that accepts a month and returns the current season?
Yeah, a function that accepts a month and returns current season. And then, after that, write a function that accepts a season. And how about...
Actually, that might be an easier way around to do it.
No, I want both.
Take out line... Oh, okay. I was going to say that accepts a season and tells you what month it might be.
But then we want a function that accepts a season and a day index for a day within that season, and returns a projected temperature.
You do remember this is the 101?
Yes.
Not the 102.
Using the following formula. How about have it be spring is day plus 1. Summer is day times 100. Fall is day minus 1. And winter is day divided by 100. And then write a main function that asks the user for a month and returns the projected temperature. There we go. Two functions and a main function.
I'm personally confused.
Well, I wanted the enum to switch on some sort of mathematical operation. I mean, if you have a better idea. It isn't an interesting
No,
problem.
I'm just confused by your description of, because we've got a season and a day index.
Yeah, I needed some sort of the day index within that season, just to have something that changes per day. I don't know. Or how about?
Have you got anything, Jason, just to stop us casting around for too long?
All right, I'll take off.
No, I thought. Go ahead, Nelson.
Or did you think this?
Go ahead and take that off.
Okay, takes in a season and returns an arbitrary projected temperature. I mean, is that better?
Yeah. Yo, Steve, what's up, man? And Bob, don't go start smoking because of Nelson. That'd be bad. Especially if you've already quit. Yeah, I think that's good, Nelson.
Cool. Well, in that case, we will pause the video. No, somebody will pause the video. I won't.
Okay,
That would be...
we are resumed.
All right. So let's see, were there any problems? Oh, also, can you make me an organizer, please? The Jason that's currently not an organizer.
We did have somebody ask, is it possible to use an enum for a return type?
Yes.
Like season, you get season, month.
Yeah, absolutely.
Why do I have breaks after the return in the switch statement? Because that's how I code. Technically, you don't need them in this case in C++, but you would need them in C#. So that's just how I code. I would prefer to see the breaks there, however, be consistent.
Will you actually get an error thrown in C# then if you don't have the breaks in?
Oh,
Even
yes.
though you're returning
Yes.
before it. Huh.
Actually, let me think about that. Are you sure, Nelson?
Because surely break comes under code that won't be ever reached.
I'm almost sure about it. I'm launching VS on another machine right now.
Cool.
I think I just ran into that not too terribly long ago, and it seemed like you didn't have to have the break. But don't hold me to it.
Yeah, I can kind of read it, but I can see why you wouldn't need it, because you're returning. But equally, I quite like the idea of, if it's a case, it ends with a break, or it falls through. And so, is there anyone who's completely flummoxed by this?
Well, people did have some questions. Is it possible to use an enum for return type? Yes. Regarding namespaces, if I declare a variable within a namespace, is it global within the namespace in the sense like global variables would be? Yes, it's global to that namespace. When I print out the enum value with cout, I get int number and not the label. Yes. When you cout, or when you print a enum, it will print out the integer value that corresponds to the enum, not the enum itself.
So is there a way to...
No.
Excuse me, is there a way to... no.
Okay, so is anybody confused about this before I'm going to go ahead and jump in and just write it?
We'll dive in and write it. I don't think... there shouldn't be any huge... I think we've covered this in quite a lot of
Okay.
breadth in there.
So write an enum to track the current season. So enum season sprint, wow. Spring, summer, fall, winter. And then have a function that accepts a month and returns the current season. So search, wow, my brain is just, there's lots of words that starts with S. A lot of words that start with S. Get season int month. Okay, so hold on. Spring.
Wedge Bob, since when were November and December not in winter? You carry on writing your code. I'm just intrigued by what Wedge Bob said.
Winter starts in March, right? So if month is greater or equal to 3 and month is smaller or equal to, actually I can just do this a little bit nicer. I can say if month is greater or equal to the start of winter, which is, oh great, December?
You see it goes across the year.
Right.
Strictly, but for a
it starts in December, right?
Well,
does it start in September or November?
Yes.
Okay.
December.
December or November. Okay, and then I'll say, I'll just add those in. I would typically wouldn't. So if month is greater or equal to the start of summer, which is going to be in June.
Well, now you can just subtract 3 from each number.
Oh, right. So that's going to be 9, which is going to be fall. If month is greater or equal to 6, then return.
Wow.
Maths are hard.
They are.
Other ways, if month is greater or equal to 3,
yay!
Return spring, otherwise return winter. So very straightforward code. And then write a function that accepts a season and returns an arbitrary projected temperature. So I'll say int get temperature, get temp, switch on season, case spring, return, I don't know, let's see, in Anacortes, that's going to be like 60 degrees Fahrenheit. Case summer is going to be like 80. Case fall is going to be like 60 again. And then case winter is going to be like 40.
50 below.
Actually, because we're an island on the Pacific, our temperatures are actually rather mild. Because of the ocean. Okay, so greater or equal to 12 will not work. Well, it will work. I mean, actually,
no, that works.
It will
could just be equal to.
It
but
could be just equal to as well.
In fact, for security, if you did month.
Well, I could just say month equals month modulus
12.
12.
Yeah.
But anyway, so write a main function that asks the user for a month and returns predicted temperature. Cout. What month do you want to know about? Int month, sin month. Cout the projected temperature is get temp, get season, month. Actually, I'm going to go ahead and just open this up in a new solution so it doesn't clutter the other example code.
Yeah, good idea.
Okay, so now I can go ahead and run, and I can say, what month do I want to know about? 5, and it says the projected temperature is 60.
And again, you just want to make it so that all the code's visible for people to see it all in one place. Putting the top on the left would be more sensible, but hey. Hello?
Hey, got a problem in season. What's your code for season look like? Explicit type missing int assumed. That sounds like you don't have a. Oh, do you not have? If you have, you'll get that error if you do this, I believe. It's like season gets season. Oh, you have to define your season enumeration prior to the function that returns a season.
Nelson, can you please put the top of the file on the left-hand side and the bottom of the file on the right-hand side? You know, like we do it. Well, particularly when the order, then like that question, the order of things matters, which order they actually happen in.
Yeah, you're missing a semi on your enum. Remember, semi. No, this is not PHP, Wolfrey. Yeah, never forget this. My lesson came with a 30-minute debugging session where, unlike most languages when I spent most time debugging runtime issues, this case was me debugging a compile time issue where I had forgotten a semi in one of my header files that was being included 3 levels deep that I forgot about. And the error was appearing on the CPP file that the H file was included in. 30 minutes to debug that problem. So after that, I've always never forgotten the semi. And remember, the reason that the semi is here is because enums, actually, typically, in C, when C was created, you had basic enums and basic structures, but you always had to define, for every time that you wanted to use a structure or enum in C, you had to define the enum or structure in its entirety before every variable. There was no way to alias it out like this. So you would use what are called type defs, and the syntax would look really nasty. And the reason that you had the semi here was so that you could create objects of the type that you defined when you created the type, because that's how it worked in C.
So we should really be thankful that we just don't have to write all that stuff.
Yes.
And it's just a semicolon. So literally, anyone not get somewhere close to that? Anyone not see why that's doing what it should do, really? Because then I think we're going to move on to, well, something you just briefly mentioned then.
Well, I want
Struct.
to try something first.
Oh dear.
What?
You missed, you've got a left bracket where you should have a right. I mean a right where you should have a left after season. In that line.
In this line?
After season.
After season? No, that's right. Because I'm casting 1002 season.
Oh, I see.
And it's printing... Wow. You know what's happening? This is funny. The parameter is getting pushed on the stack, And then because no return value is being pushed on the stack, when C++ or the runtime goes to pop a value off the stack, instead of getting a return value, it gets the parameter that we pushed on.
Ugh.
I do want to point out that this code, because this is a problematic piece of code, I would go ahead and add either a default case and return -1 and a break, or add a return statement after the switch, so that this doesn't happen. Because now we'll get -1, like we should.
So, sorry, I'm still slightly unclear on what was happening there.
What was happening is the argument was getting pushed onto the stack frame of getTemp, so that it was provided in the season variable. And because there was no return statement, no return value was getting pushed onto the stack as well. So then when it returned, it immediately popped the value of the parameter and not the return value. Which is hilarious. I love C++. Okay, but yeah, make sure that you have a default case.
Structs.
Okay, so I guess nobody is having any problems with this, so let's move on to structs.
Sweet.
What
is a struct?
Well, a struct is... I'll give the academic definition of a struct first, which will help everybody who is familiar with other languages, and then I'll go into why we use them. But a struct in C++, all a structure is a class where the default accessibility is public. Now, if that doesn't make sense, that's fine, but if you know what a class is from other languages, all a structure is in C++ is a class with the default accessibility of public. That's it. It is behaved, treated, and worked with just like classes, except for the default accessibility is public. So let's go ahead and talk about what we use structs for, at least in the basic concept of using a struct. Generally, a structure is another type that we can use, but it's a little bit more complex than in Enum. See, an Enum is a data type that only has a range of specified values. A struct is a data type that allows us to add attributes to objects or to runtime variables. So for example, I can say struct product. Now notice what I did. I typed in the struct keyword, I gave it an identifier, I opened up curlies, and I added a semi. Again, the semi is just as important as it is for enums, and it behaves the exact same way as enums, meaning we can define structs inline inside of our functions. So I'm going to go ahead and include a string. I'm going to go ahead and say string name and double price. So what I have done is I've created a new data type that has 2 bits of data in it. So every time I create a product, what I'm actually doing is I'm creating a string and a double. And I'm naming both the string and the double something that I can access later. So now inside of main, I can say product p1. And then I can say p1.name equals product1, p1.price equals 32.32. Then I can write a function. So for example, I can say print product. And I can say cout name product.name cout price product.price.
Do you want to give it something else?
Like, I don't know.
Quantity in stock or something? Yeah, something like anything really.
Now I can say print product, and I can pass in p1, and when I run this code, the console window will immediately terminate because I'm stupid. And now it won't compile because I didn't release shift fast enough. And you'll see name product 1, price 32.32, notes. These are notes for product 1.
Yes. Sorry. I was going to say, did that answer your question, Barry? But I guess it did. Yes.
Okay, so a structure in C++ and in C is a thing, a template for a variety of data attributes that we can add on to that template. Now, we are going to be going much, much more in detail into this style of programming on week 7. But for now, we're not going to be talking about member functions. We're not going to be talking about inheritance or any of the other object-oriented features. We are treating structures as simply a bag of values that we can pass around. Are we creating
Mohammed has brought up an interesting point. He says, we created a struct object without the new keyword?
Yes. We created an instance of a struct without the new keyword. What happens here is product is placed, the data for product is placed on the stack. There's literally no difference between doing product P1 than doing string P1 name, string P1 notes, and double P1 price. As far as the layout in memory, this is completely identical.
It's just a way of joining related things together, really.
Yes. So the benefits that we get is now we can pass around this bag of properties into other functions without having to specify everything inside of it. So instead of having print product, instead of having a method like this or a function like this, print product string name, string notes, double price, we can simply have a print product function that takes in just a product structure called product. Okay, how's everybody?
So, just another one from Hamid. So struct goes to the stack and classes go to the heap?
No. Whether or not an object goes onto the stack or the heap in C++ is determined by the use of the new keyword. In other languages, that's not true. The new keyword may or may not allocate something to the stack or the heap, depending on a variety of variables. Generally speaking, C#, the main thing that it looks for is if what you're trying to represent is a structure or not. Even then, it still might place it on the heap, depending on implementation details. But in C++, whether or not something is placed on the stack or the heap is something that you decide every time that you create an object. And you decide this by using the new keyword. And we're going to go over that more in next week.
And so it's a really basic class, conceptually. This is the thing, because I mean, you said that the only real difference is between you can think of it like a public class, a class that is default. What words and things? What you said earlier.
Yeah, unlike other languages, C++ makes no differentiation between classes and structures, other than structures are by default public. That being said, using a class instead, or using a structure instead of a class, you typically use structures in cases like this, where you are treating the structure not as a fully fledged object in the context of object-oriented programming, because we're not discussing object-oriented programming. You use it in this scenario where you have a bag of properties that you want to pass around.
See, but yes, I mean, so why wouldn't you just use a public class instead?
There's no difference. But the difference is the typical use case. The difference is when you see the keyword struct, you think a certain thing. When you see the keyword class, you think a different thing.
Yeah, I was just...
We haven't learned what a class is. Just ignore the existence of classes. And I know that's probably confusing people, but then again, there's other people who already know other languages that will be getting confused by this if I don't at least give a cursory overview for them. But ignore what a class is. We're going to be talking about that in depth in week 7.
couple of people asking, but which week was it? At some point in recent weeks, we definitely went over the stack and the heap.
Yes, that was last week.
That was last week. Good.
No, access modifiers are not only for classes. I heard the structure guaranteed to be stored in order declared, but a class is not. Possibly.
Can and should you define defaults to the values inside of the struct definition?
Typically, we're not going to be worrying about field initializers because that's going to be covered in week 7. The only reason I'm introducing this is to get people to start thinking about grouping together related data. That's it. We are not using any other features other than public fields, period. The only features we are talking about are the keyword struct, followed by identifier, followed by an open parenthesis, followed by a list of attributes, followed by a closed parenthesis, and followed by a semi. We're not going to be using methods, access modifiers, inheritance, polymorphism, virtual members, initializers, constructors, destructors, or dynamic memory allocation. All we're talking about is what is seen right here.
Bag of related things.
Yep.
So you can have, presumably you can have arrays of structs.
Yes, but I first...
It's just a type.
Right.
Sorry, I was just going down the questions.
So wait, so someone's talking about... can we place functions in structures, and if yes, what do you call them? You call them methods, but that's irrelevant. Yes, you can have methods and structs. No, we have not talked about classes. Yes, we can put functions in, well, functions become methods when they get put in structures. I heard that a structure is guaranteed, can access blah, blah, blah. You didn't go over the heap. Okay, well, the heap is going to be gone into detail next week with pointers, essentially, when we talk about dynamic memory allocation. So far, we've only covered in depth static memory allocation, or at least allocation of memory on the stack. And this is what we're doing right here. By using this syntax, we are allocating every single member that's within the product type onto the stack frame of main. Okay, so basically what we have here on lines 21 through 23 is a product data strewn across 3 separate variables. But that's not very useful in a lot of cases because it requires us to do a lot of work. For example, to pass this data into a function, we have to create a function that accepts all 3 of these parameters. However, by abstracting these attributes into a structure, what we've done here is we created a thing, a bag of data that we can pass around at our will into other functions. Does anybody have any questions about this code as it appears? And maybe I can add a little bit more Okay, so this code, I'm forgetting a send.ignore. Okay. Are there any questions about this code specifically? For people who are completely new to programming, I really want you guys to ask questions about what we have here, this struct, this type we're creating, and how it relates to these functions, that one of the functions accepts a product and the other one returns one. And what we're able to do is make a very clean and succinct main function by invoking our getProductFromInput function and then immediately turning around and invoking the printProduct function. Could you say why we need structs? Basically, you could do the same thing with a class by using public members. We're not talking...
Basically the same thing I asked you earlier.
Yeah, we're not talking about classes. Structs, the keyword struct carries a different connotation in people's minds.
I think what you're saying is what connotation should it be carrying in our minds?
Simple bag of properties, essentially.
Well, there's nothing happening in the questions panel, so I guess that's all crystal clear to everyone. Oh, no, we've had one come in. Is it convenient to create a function to set values to the variables? Is it convenient to create a function to set values to the variables to structures?
Is it convenient to create a function to set values to the variables?
Like a factory, probably.
Are you referring to this function right here, get product from input? Or are you referring to... Because...
Default names and things, perhaps?
One bit of syntax that you can use is structure initialization.
If anyone's confused by this, don't panic. This is slightly extra information.
Right, but I think the question had to do with this. Basically, what you can do by using the curly brace syntax, we can set all of the fields of the structure in order. So, for example, this first field goes into the name, or this first value goes into the name field. This second value goes into the notes field, and this third value goes into the price field.
Does IntelliSense help you with that?
Nope.
Can you use, just to clarify in that, can you use name equals product one and so forth in that if you didn't want to set everything?
Never tried that before. The answer looks like it's no.
Okay. I don't want to get too off into more advanced stuff, but I just
should get product from input be inside the product structure? No, because we are not talking about member functions. That's really not the point of this. The point is we're writing code right now. Almost everything that we've been doing so far has been stuff that we could have done in C, more or less. Obviously, C does not have the string class, nor does it have the CIN and COUT class, or the namespace STD. But this, like I said, this entire week is to cover a few basic concepts and to get people ready for the discussions about object-oriented programming and pointers. Because what we have right here is a very basic sort of object that is a very useful construct without having to bog down this concept with a bunch of extraneous information that might not immediately seem useful until you get into the practice of conceptualizing your variables as not just free-floating data, but as concise, grouped together, meaningful bags of named values. But you couldn't use a class to do that, at least not like that, right? If I changed the keyword struct to class and added in one more keyword, then it would work just as fine. But structs were more or less carried over from C, their legacy things. But the reason that it's useful to have structs is because they do carry a connotation when other developers read the code.
Somebody asked, when you declare the struct product P1, does it call a default constructor at that point?
No. There's no constructor. There's no constructor to invoke. Sorry for beating the subject, but don't get me wrong. I see the point of structs. They don't exist in Java, for instance, and you can't accomplish the same thing with classes. Is it legacy from C? Yes. Structures exist to be compatible with C code. Yes, please. Everyone look at the screen very closely. Flash, you no longer know what a class is. Yes, thanks, Buzzcad.
That is quite apt. I was thinking about the prisoner, and I'm not a number. I'm a human being.
Okay, can you put structs into an array? I will get into that. Actually, that's the next thing I'm going to be getting into. But I need to make sure that this code makes sense for people. In fact, you know what?
What?
I'm resetting everybody's ready button. Type this code out. I'm pausing the video. And we are resumed. Okay, so are there any questions about structs? At least using structs for a very simple use case in C++.
Are there any questions about structs that don't involve the word class?
Yeah.
Because they don't exist. Yet. I think we're good to go.
I'm surprised.
Well, you're just, you're the teacher from your Uber teacher with a capital Uber.
Still strange behavior with getline. I don't.
I see nothing in the webinar questions panel, so I'm assuming.
Ooh, I accidentally commented out the wrong one. Thanks for catching that, Gavin. And I accidentally kicked a dog. I'm sorry. Seriously, he crawls under my desk and then.
Wow, you just really broke, didn't you?
Yeah, I think I did. Oh, right.
You're doing see out and get line there.
Because I forgot to send out ignore. See, because the send get temp price didn't eat the new line, I had to do a send dot ignore before doing the get line here. It says print product is undefined. Make sure that print product is defined above everything. And make sure that you have a semi right there, because if you do not have a semi right there, you will get an error. Ooh. Look at that.
Wow. A helpful, accurate error message.
I am absolutely surprised that it actually... Wow.
Oh, you forgot the semi as well. So.
Yeah, I wish I had that with my 30-minute debug. That would have been nice. Okay. Arrays of structures. Well, basically, I can create an array of structures. I'll actually create an array of 3. I'll say for int I equals 0, I smaller than 3, I plus plus. Products at I equals get product from input. See out. And then I can say for int I equals 0, I smaller than 3, I plus plus. See out.
Copy and yeah. You know what I said to you yesterday
Yes,
about?
I know what you said.
That's what I meant.
Okay, so now I can enter 3 products, and so enter name, product 1, price, product 2, product 3, and then I get them printed back out. And then, because this is an array, we can do some interesting stuff with it. I can say something like product most expensive, and I can say for int I equals 0, I smaller than 3, I plus plus, and then I can say...
Well, you could get them to do this as a...
Actually, yeah.
Because it's quite straightforward but useful.
Okay, I'm going to go ahead and pause the video. Everybody has this typed out already. except for this bit right here. So go ahead and type out main, and then write a for loop that gets the most expensive product, and then displays it out using the print product function. So get most expensive.
I think it would be good to get them to make a. Would it not be good to make them get most expensive function?
That would require passing an array as a parameter.
Oh yes, sorry.
Which we are carefully tiptoeing around. Okay, I'm going to go ahead and resuming. Okay, so what we would do is we would say if products at I.price is greater than most expensive dot price, then most expensive equals products I. And then we could actually just do this. We could say I equals 1 and then set most expensive to initially products at 0.
That makes sense.
Then
just do the first one in line.
And then we can say...
It's worth pointing out that this doesn't actually... Well, no, sorry, yeah, finish that off and then I'll point out why it doesn't actually give us necessarily the result we want.
Why doesn't it? Unless I'm missing something.
Really?
What am I missing?
Well, no. Think about possible use cases. In fact, can anyone else come up with the answer? What I'm talking about? There's a use case where this could be problematic and won't necessarily give you the answer that you're expecting. There we go. GG409 is the winner.
Oh, same price. Ugh.
What happens if you've got two items, and they're both the same price?
Then you just get one of them.
And most expensive. You just get one of them. But I thought it was worth pointing that out because...
Okay, so now I can enter in 3 products. Bleh. Hey. And whoa. And it says most expensive product is a hay at this price with these notes.
Cool.
Okay. So, and here's the print product function for that person who's asking. Okay, so let's talk about STL Vector really quickly, then we're probably going to jump onto a break, because STL Vector is very straightforward.
What is STL Vector?
Okay, well, so we've talked about arrays, right?
Specifically, what isn't a vector? A vector is not a vector, as in a C# vector.
No, it's the data structure vector. Okay, so we talked about arrays, and arrays are nice because they allow us to group a bunch of data together in a really nice, clean way, and everything's all great and stuff. But the problem with arrays is we can't size them dynamically. So this program can only allow for 3 products because the product array is typed or is set to only being 3 items long. Now this typically isn't what you would want. Generally speaking, you would want some sort of dynamic memory allocation that allows your program to grab more data from the operating system as it's needed by your program. But we're going to be talking about dynamic memory allocation in week 6. What we're going to be using now is a class that is created for us, part of the standard library in C# or C++, part of what's called the STL, or the Standard Template Library, which is called a vector. Now, it's very similar to a string in that behind the scenes it will dynamically allocate memory for us. So how do we use the STL vector? Well, the first thing we need to do is include it. So you must include the vector header. Now, using a vector is very... Well, I'll just...
Did you say it was part of the STL namespace?
It's part of the STL. It's part of the STD namespace, but it's part of the STL, which is a subset of the standard class library in C++.
That's cool. I was just checking because obviously you didn't do what I was expecting you to, which was add in a thing at the top for STL.
Okay, so what I did was instead of creating an array of products, I created a vector of products. You'll notice something a little funky right here. Now, those of you who are familiar with lists and C# will already be familiar with this, but those of you who aren't, this might look a little confusing. What we're doing is we're creating a vector type and passing the product type into the vector type so that we create a vector type for our variable that allows us to operate on products and products only. Vectors are typed to one thing. So you may have a vector of ints, you may have a vector of doubles, you may have a vector of strings.
What happens if you actually do a get type on those? Do you get vector as the type, or do you get fully qualified vector as, or not fully qualified? Do you get vector of string, vector of int, vector of?
There's no such thing as type of in C++. There
I
is.
said get type.
There's no get type either.
Boo.
Now there is something called runtime type information, but it's way too ridiculous for right now.
Okay.
Okay, so a vector is essentially an array that's typed to a particular kind of thing, and it's dynamically sizable. Does everybody understand at least? You don't have to understand this syntax, you just have to be able to type it out. Vector, and it's pronounced vector of product. But barring the syntax, does everybody understand the concept? Not necessarily how you'd go about doing this, because that's what I'm going to show an example of, but the concept that a vector is a dynamically sizable array, an array that can contain 0 to X amount of elements, where X amount of elements is the upper limit of what the vector can know about, which is probably the length of an unsigned integer and or the length of your memory that you have available. Okay, so how we would use it. I'm going to change this for loop into a while loop. I'm going to say while true, and then I'm going
Then you're going to have another problem.
yeah, never ever do this, ever, 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 ever. It'll compile, it won't do what you expect it to. Okay, so, and then I'm going to say int index equals 0, and then I'm going to say index +1, index ++, and then I'm going to say products.pushback. Actually, I'm going to alias this out a little bit just to
Yeah.
and then finally, I'm going to, at the end of this, I'm going to say cout enter another product y/n if send.get equals n, then break.
And I know people are going to hate me for doing this because they seem to, but I will just say these vectors, as you have gathered, are very much similar to lists in C#, and pushback is equivalent to add.
Yes. The way that vectors are implemented behind the scenes are directly equivalent to how the list class in C# is implemented behind the scenes. So pushback adds a new element to the vector. And if the vector is incapable of storing that new item because it hasn't allocated enough space, vector will behind the scenes request more memory from the operating system so that it can continue to store your additional item. Okay, I'm going to complete this example and go over it. So this for loop becomes, instead of I is smaller than 3, we do I is smaller than products dot size. The size method returns how many elements are in the vector. So the same thing goes on right here. I is smaller than products dot size. Now you'll notice something interesting. The indexing operations work just like they do inside of arrays. If you know the exact size at compile time, then array would be fine, of course. But in reality, you rarely know the exact size of your collection.
And Bowser said, how does pushback be equivalent to add? I don't mean add as in plus. I mean
Yes.
the list.add method in C++. You use the vector.pushback method.
Yep. How do you remove from vector? We'll talk about that in a second. Okay, so now when I run this program, I can say product1, bleh, and then enter a new product, yes. Product2. Oh, come on.
You'll have an ignore problem, probably.
Yeah. Yeah, it's filling up because this sin.get isn't quite doing what I expect it to. Oh, of course, it's not. I'm just going to do char choice sin choice if choice equals and then sin.ignore. So as you see, it prints out all of our products after we said that we didn't want to add another product, and then it gets our most expensive product that we've added.
Cool. I wanted you to answer Jeffrey's question. Is there any logical explanation to why it's called pushback?
Yes, because there's also push. Actually, I don't think there is no push front in vectors, but there is a push front in lists, which lists are linked.
I'm with you, Barry. It's a stupid name from a... No, it is a sensible name, but it's just not as transparent a name.
Yeah.
It's actually more specific.
Pushback is you're just pushing something on the back.
I'd always read it as push back as opposed to push to the back. If you think about what add does, it adds an extra item at the end of the list, and this does the same thing. It pushes something at the back of the list.
Yep.
The back of the vector.
Should be add back. Okay.
Is all this making sense so far?
Are people good with this refactoring? I kind of want to get people to write this out as well, because they should already have this code written. It's just the only difference now is you need to transform the for loop into a while loop. Instead of setting the index, you have to do a pushback, and then you'll have to add the code that allows the user to terminate the program. So what I'm going to do is I'm going to go ahead and start a 10-minute break, and I encourage people, I am going to reset your ready checks, and I encourage people, especially people who are new to this whole thing or the concept of a dynamically resizable array, to go ahead and change their code. And the only code you have to change is what I have on the screen. But change your code to match what I have here, where I essentially, instead of an array, I'm now using a vector. Okay, and we are resuming. Okay, so a few questions did come in about vectors. Namely, how do you remove an item from a vector? And removing an item from a vector is a little tricky. So for example, if we did products.pushback, I don't know, product p1 equals whoa stuff and things, and we did product pushback p1, and we get a compiler error because notes comes before price. If we wanted to remove this item, We do have a actually, I forgot. Vectors don't have a remove item. Vectors will have an empty method, or an erase method. Sorry, an erase method is. See, I always forget it's the impedance mismatch between vector and list. Now, here's a thing about the erase method. The erase method is a little bit more complicated than what you would expect. You can't erase an item directly. So I can't erase P1. That would be an error. And we get this really nice error that looks really terrifying, because in fact it truly is. This doesn't have to make sense, but what's going on here is erase is expecting another thing. It's expecting what's called an iterator. So it's expecting that we do products and we find a item, or we find an iterator that we want to remove. So the problem with that is that requires talking a little bit about iterators, so I'm not going to talk about removing just quite yet, basically. For those of you who want to look at some quick code,
and this is code which really, if you understand it, that's good. If not, don't worry about it. We will be getting there later in the...
So let's say we wanted to remove the item with the name of woe. This is what we would do. We would enter a for loop, create a iterator to the beginning of the collection. We would only continue to loop until we reach the end of collection, and every time the for loop runs, we increment the iterator by 1. We then check on line 42 using the special syntax that is actually overloaded for iterators specifically to get the current product that we're currently iterating over, and we identify its name as woe. And if we do, then we invoke products.erase at this iterator. Now I want to point out this iterator, I did use the auto keyword here, and I used the auto keyword very specifically because if I hadn't, this would look like that. So the auto keyword is a very nice little thing that we can do right there. Yes, empty. The empty method is going to, actually the empty method is not going to do what we expect it to. I forgot about the, see, it's clear is what empty would think that you would do. Empty returns a Boolean if the collection is empty or not. Clear will clear every item out of the vector.
And yeah, there are a couple of questions about some of the methods in the vector, because push off and also pop back would seem to do things that might be related to this, but
I don't want to go too depth into the STL, because the STL, every STL collection has very similar methods, and I would kind of want to talk about them all in conjunction with each other.
Yeah, yeah.
Is star I loosely current I? Yes. Star I is saying, give us the current product we're looking at. But it's okay if you don't understand this code quite yet, because we are going to be talking about STL containers in more depth at some point. But this is how you would remove a specific item from the list. Is that for dereferencing pointers? Yes. The star is used for dereferencing pointers, but it's overloaded in this context to do something else. Okay.
We're getting a bit beyond
right. So
where we were going to cover.
Basic use of vectors is what we see right here. I do want to point out that I made a mistake by putting in int I right here. I should have put in, actually specifically I should have put in what's called a size type, which is declared depending on the allocator basically, which is a kind of archaic thing.
It's basically a way of saying if this is something that iterates on a float, then we'll use float. It's kind of like a type-specific way of finding it out.
Well, it's less about the it's more about the allocator than the type. But the idea is that it could be overridden to anything you want. So what you could do is you could say vector product. I believe we can go ahead and access size type right there. By doing this, we get the proper type. However, another acceptable way to do this so that we avoid the warnings, which again is signed unsigned mismatch, is simply declaring I as an unsigned int. A more appropriate way would be to do this, but I understand that this is kind of scary looking. Acceptable way would simply to be using an unsigned integer, because ultimately that's what the size type does boil down to in this instance.
Is that what auto would resolve to then?
Auto would resolve into an int because we're initializing it to 0.
Gotcha.
We're not initializing it to anything out of products. Are vectors like list in C#? Yes. Vectors are almost completely identical.
Cool.
Okay, so I guess that's it for vectors, if everybody's cool with vectors. So let's talk about file input and output really quickly, and then let's talk about homework. Now, file input output might sound really scary for people right now, but it's really not, because we have already, fortunately, C++ is very consistent in how we read to and, or how we read from and write to
and read from
files, or streams of any type. Actually, what I'm doing, I'm actually going to copy and paste this example and tear it up a little bit. Okay, so what I have right now is the example that we had before, where we have the print product and get product from input. I'm going to collapse these methods because we should already know what they do by now. Okay, so let's talk about writing to a file really quickly. Again, really straightforward stuff. All we have to do is use the two different types that are defined in the fstream header. So if we include fstream, we get access to two nice types. We get a OF stream and an IF stream. Now the OF stream type is used to output to files, and the IF stream type is used to read from files. So let's go ahead, and I'm going to create a few products in our vector. So I'm going to say product P1 equals product 1 notes and price. And I'm going to go ahead and do P2, P3, P4, 2, 3, 4, and then maybe give these different things, and I'm going to add them all to the products.
You have actually ended up there just by sheer habit with two products with the same value, and they are the most expensive. So I point that out.
Okay. And there we go. Okay, so let's say we wanted to write all of these products to a file. Well, we start with the IF stream type, and we're going to call this fin. F-I-N. Or, sorry, we start out with the OF stream type, and we call it FOUT. F-O-U-T. Now, me calling it F-O-U-T is just a convention. It just is synonymous with C out. So I'll typically call this FOUT, F-out. So that's our stream object. How do we point it to a file? Well, we do FOUT.open and then pass in a file name. So the file name is going to be products.txt, and then we're going to give it a mode. Or actually, I'm not going to bother giving it a mode. By default, it'll OF stream will open it up in read mode. Okay, so how would we go about writing all these products to FOUT? Well, just like we do with cout. I can say for unsigned int I equals 0, I is smaller than products.size, I plus, and I can say FOUT and then use just the normal syntax for printing out to a file, and I can say products at I dot name products at I dot price, products I dot notes.
Aren't you going to have problems now?
I'll show that in a second.
With no spaces? Okay.
Because this will unfortunately introduce a small limitation with things. Okay, so then at the end of this, I'm going to say fout.close. So
It's most important.
yes, by closing it, I clear the buffer. So anything that OFStream has kind of contained in its internal buffer gets immediately pushed out to the file, and the file handle gets removed, giving it back to the operating system so we can open up the file again, or write to the file again.
And presumably not doing that, forgetting that close has memory leakage implications, does it?
Well, I'm not sure about memory leakage, but it will have resource leakage, where we've allocated a resource and we never deallocated. What's the include needed for this? fstream. Okay, so if I run this program, and I don't have any input or output, all it did was print directly to the to fout. If I go ahead and open up, locate this project on my hard drive. Actually, you'll notice something very interesting right off the bat. The way that Visual C++ scopes our file is not to the directory that the executable is in. When I say products.txt, this is a relative path to the current directory. And here's the important thing. When you're running in your debugger and you're running inside of Visual C++, the current directory is not the current executable path. Instead, it is the path to your project. So you'll notice a products.txt file got created inside of our project. However, if I was to double-click on this executable directly from within the debug folder, you'll notice a products.txt appears right here. That's because the products.txt, when running inside of Visual Studio, is going to be relative to our project path. But when we just simply double-click on the executable, the path is relative to the executable.
So if the executable was on the desktop and he double-clicked on it, he would get the text file on the desktop.
Yep. Okay, so now when I open up products, you'll notice that we have product 1, 2, 3, notes, product 2, or product 1, 23, notes, and so on. So you'll notice that we never delineated our different fields, which is problematic.
Well, I told you so.
Well, I knew that this would happen, but I just wanted to...
Yeah, no, I didn't know if you were going there anyway. Okay,
so if we wanted to format this in a way we could read back for later use, what we would do is we would delineate our strings. Let's delineate our strings by new lines. Now, I want to point out that in C++, this new line does get converted into the platform-specific new line character that we want. In this case, /r/n. And then price is going to be on a new line, and notes is going to be on a new line. So now when we run this program and open it up inside of here and open up products, you'll notice that we have product 1, new line, 23, notes, product 2, new line, blah, blah, blah.
See, I'd use commas for those first two new lines.
The commas are, we'll talk about that in a second once we start talking about reading them back in.
Okay.
Okay, does anybody have any questions about what we're doing right now? All we're doing is we're printing out to a stream. The OF stream will behave just like cout. We can use the same sort of anything for it. It will behave exactly similar to cout. It's basically just a version of cout that prints to a file instead of the console.
Well, let's move on and see if any questions come in. We can round up at the end.
If the file doesn't exist, does it create it? Yes, the file will be created, and it will be, if it is already there, it'll be deleted. Not deleted, but erased, truncated. We're not going to be talking about appending yet. Okay, so now that we've saved products to our products.txt, how do we load it back up again? Well, that's going to be done with the if stream, and I'm going to call this fin, just like cin.
And it is if stream.
Yes, if stream.
It's not if stream. It is an input
file stream. So now we can do, and is there a merge option? There is, but we're not going to be talking about appending. I want to keep things as straightforward as possible at the moment by just using the default overloads of open. So what we can do here is we can say fn open products.txt, and then we can say fn.close. And you'll always want to pair every open with the close. This is very incredibly stupidly important. So now how do we read from a file? Well, let's say we wanted to read every line of this file and print it back to the text console or the console window. I could say while not fn.eof. This means while the stream is not at the end of the file, continue to execute this file. What I'm going to do is I'm going to say string line, and then I'm going to say get line fn line, and then I'm going to go ahead and say cout line. Will it crash if there is no file? Depends on the behavior of fn, depends on how you configure it. I forgot the default behavior, sadly.
And can you just highlight the lines of code that are actually doing the saving and creating of the file?
Yeah, this saves the file. This loads the file back in and prints it out line by line. So we have.
And when he says saves the file, that if the file does not exist, will create the file. So are there any more questions about that? Because we are really we could do with.
Go ahead and run it and demonstrate a problem though, because Rolling Stone actually pointed out something I forgot. That the get line does not actually get the new line. So when we see out it, we're going to go ahead and have to hit /n. And now when I run it, you'll notice that all of our products do indeed get printed out. We're going to be talking, after this, we're going to be talking about how to read that data back into the vector. But for now, is everybody okay with this, loading in the file line by using the getLine function and using the ifstream.eof method? Should I use clear before close? No, a close will do a flush for you, so you don't have to do anything after a close. A close will do every little bit of bookkeeping it needs to. There's nothing that you have to add before a close. I see what we're opening with fout, but how are we saving and creating files? Well, fout, when we open it on line 49, it'll create the file if it doesn't exist. And then every time we type into fout, by using the same syntax as cout, we are sending data into the file. And then we close it and we write everything into the buffer. You mean this far, Bob, or further? Okay. Last thing, how do we read back into a vector of products? So what I'm going to do is I'm going to create a vector of product called products2. Products2 is what I'm going to read the data back in as. So imagine the program, right now we're immediately saving the vector and then immediately saving it to a file. But I want to point out the fact that products2, imagine that this vector exists after we had relaunched the program and we weren't immediately saving up. So when you do fout stuff, you really are writing to a buffer in memory, then close writes the buffer to the file. That's mostly correct. This will very likely go into a buffer. basically we don't have control. Well, we do have some control over the buffer, but typically it's not something you would want to worry about. But fout is allowed to buffer as much text as it wants until it actually does a write to the disk. So this might go into a buffer. It probably will, but it also might go directly to the file. And then fout.close will guarantee to write everything that might be in a buffer directly to the file. Okay, so how would we read back into a list of products? Well, the first thing is we would create a product temp, and then we would read back into it. So let's start by saying getLine fn product.name. Then we would say fn product.price. Then we would say fn.ignore to eat that new line. And then we would say getLine fn product.notes. So we're doing is saying while we have more data on this file, while if fn.eof, create a temporary product, get the first line and set it to its name, then grab its price, then ignore the new line character, and then grab its notes. So after closing the file, we can now loop over the entire product. So we can say products read from
you could
file.
just copy lines 51 to 54.
What?
You could have just copied lines 51 through 54 for this bit.
Yeah. Well, obviously, we're going to have to actually add that temp products into our
Yeah, that would help.
nice little vector. Okay, so what we have done is between lines 58 and 86, we have created a new vector to store a vector of products. We've created an IF stream called fin. We've opened it to products.txt. We've entered a while loop saying, while we're not at the end of the file, create a temp product, grab its name, just like what we do with CN, grab its price, and then ignore the new line, and then grab its notes, and then add it to our products vector, close the file, and then loop through everything that we just read in and print it out. Any questions? Because this about wraps up the demonstration of basic file input and output.
Bum, bum, bum.
Like, seriously, guys, this is like the end of the class.
And yeah.
Yeah, the file is just a text file, and I accidentally launched C# for some reason. That looks like this. Which one is better, products.I or products.at.I? It really depends on what you're trying to do. But I would just use the array index without getting into the STL more in depth. I would use the array index syntax because it's going to be a lot more similar to what you'd expect.
The new lines.
So what is making everything to be put on its own lines on the file? New lines. I added in new line characters to be printed out after every field. And then that's important because I had to eat that. See, the getLine function eats a new line. However, when I grab a price, that does not eat the new line, so I have to ignore that. Otherwise, this getLine would return an empty string, and we would be out of sync. Could you run yours?
Go ahead and run it just one more time. This is the last, really got to be the last call for questions about this, because we've got to move on. By eating it, he just means discarding it, throwing it away.
Oh, did you forget how to make the Enum syntax writing looks... Oh, I did. That's actually a really quick question. Let's say you had an Enum like seasons. Instead of doing this, winter, fall, summer, spring. Instead of doing this, you can do this. So now I can say season E season equals season at winter. And this is completely valid cross-platform C++.
So why does it display an extra product, product 5? Which is a good point.
Why does it display an extra product? Oh, because of this new line. Actually, the new line on the last product is making it so, or at least that's my theory. But I can't, I'm going to make a post in the forums about that later. I don't have time to get into that at the moment. Because that'll take longer than 3 minutes.
Yeah. But bear in mind, we have got an open office.
Yeah, and I'll make a post on the forums about that as well.
Who finds problems as they go.
Okay, so the struct, does this make sense for the special syntax to get this to work? It's really straightforward. You're just encasing an enum inside of a structure that has a name, and then you're giving the actual enum a name of E. So you do season : E to reference the type, and then you can qualify each one of the enum values with that, so it doesn't clutter anything. I honestly really do prefer this. I mean, what are your thoughts?
I'll tell you what. How about? What I was just thinking. What are you thinking on? How about gisting this? Take that season example back out again, but gist the simple example of read from and write to.
Yeah.
Because it is something that you need to be a bit careful about, doing things in the right order. And you people have to understand how much I hate myself for suggesting that. You should all have typed it out when you wrote it.
Okay, to the open file area? Yeah, this is the open file area. Okay, so let's really talk about homework. Not surprisingly, actually I'm going to do that on my main computer. Not surprisingly, homework is going to be to continue last week's homework. Allow for 0 to many products to be added. Use a product structure to contain a name, price, and description. And finally, every time a product is added, print all products to a file. Every time the program is started, read in all products from a file. And we also continue to
I take it we're not worried about whether the file exists, but
yeah, that's going to be if you cast a stream to a Boolean, it'll indicate whether or not the file is in existence. So if I say if fn, then the file is in existence. If not fn, then the file is not. So if fn, then cout file exists. Actually, well, you have to go ahead and make sure that the Boolean it is cast to a Boolean. So another quick example. But again, I'll be making a post on the forums to cover a few things that we don't have time for because of the class that's starting up. Okay, so is everybody good on the homework? Basically, we're now using vectors instead of arrays, and we're grouping everything into products. Continue to use the separation of header and CPP files and anonymous namespaces to contain the private data, and then allow a person to add as many products as they want to the system. And finally, in main, have a basic state machine using Enums for a main menu that allows you to add a new product, B, sort products, C, display products, and D, exit program.
And we are going to be, I'm going to start being stricter on things like D here, exiting the program being an option, and not just being forced to click the red X in the corner. There's these sorts of things. This is a brief. You've got to work to the brief you're given, not some approximation of it. And I've shown remarkable laxity on that front so far. So you've been warned.
And I do want to point out main will have no line limit, and the reason is we haven't discussed a way to transition between states if we were to break each state out into their own functions. So as a result, because we haven't discussed that yet, there's no way for you to do anything but have the entire state machine being represented in main, which will result in quite a few lines. That's currently unavoidable. But the line limit is the same for everything else.
Thank you.
Main as in function.
Function main. Main.cpp has a capital M.
Okay, is everybody good with this homework? Any questions? Because we're about to head off.
Everyone seems...
All right, be sure to join the open office hours if you guys have questions. Rolling Stone, I'll be writing up a blog or forum post about that. What's that, Buzzcat? Is products a struct or a vector? Products is a vector of structs. Vector of product, which means it's a vector of a structure.
Cool.
Yeah, Muhammad, are you asking about the using enums like you can C#? I did briefly explain that by encapsulating it in a structure. Did you mean we are going to have to choose if we want to add a new product, then we call the add new product function? Yes, and you collect the user input. And Musa, remember who grades the homework.
And one final question, this really will be the end. When is the open office and at what hour?
I scheduled the last one. Jason, do you have any input?
Well, I would assume we were going to do it again Wednesday. And, how was the attendance this past Wednesday doing it earlier like that? Well, actually, we can't do it earlier on... it was posted earlier on Thursday, correct?
Well, yeah, we can do a 1 o'clock one on Thursday, or a 5 o'clock one on Wednesday, or a 7 o'clock one on Wednesday.
Which one? Wait a minute. Do we have a thing coming up this Wednesday though with Aaron?
I believe so.
Okay, yeah, I thought so. Which one worked out better? I don't know what the attendance was like during the Thursday at 1 o'clock one for you.
I don't remember. Gavin, do you remember?
No, I don't. They're all a blur. Which one was it that we had lots and lots of C# questions in?
And like no C++ questions. That was in. That was at 5 o'clock my time on Wednesday.
Right, we should do the other one then.
Okay, so is that the 7 o'clock on my time on Wednesday, or the 2 o'clock or 1 o'clock my time on Thursday?
Sounds like the 1 o'clock on Thursday would be what you're describing there.
Okay. So 1 o'clock my time on Thursday, which is 3 o'clock
3 Central.
Central.
So just, yeah, make a note of that, Nelson, so I can get scheduled. And if that's everything, I'm about to have to pass the torch over to Zach here, coming up in a few minutes.
Yep. Okay.
Oh, hey, wait a minute. Oh, hang on.
I'll tell you what, we'll have to...
Is it UDK on Thursday? He's got a good point. When is usually UDK? 3 o'clock on Thursday, isn't it? Wait, so how did you do it last time?
Because Zach was away.
Oh, ha ha ha. Thanks a lot, Chris. That's a very good point. Yeah, because Zach was away, so that was an open time. And I want to try to...
And actually, people have said, yeah, Wednesday would be better from the point of view of the C# class, because obviously C# homework was due on the Thursday.
Okay, well, let's just go ahead and schedule this next one on Wednesday, since last one was Thursday anyway.
So Wednesday at 7 o'clock CDT or 9 o'clock CDT?
7 o'clock CDT, to try to accommodate a few more people.
Okay.
Alrighty. Well, let's just go ahead and wrap things up and close down the webinar. And for those of you that are coming back shortly, well, Zach will see you shortly.
All right, I'm going to go ahead.
Outside of that, we'll see you later.
Bye, guys.
Bye, everybody.